Welcome to Thursday of week 3. We want to really make sure we understand all the shape-shifting topics, everything we can do with just one number. So we're going to pretend we're taking a test. Everyone has the same copy of a test. Maybe you're fortunate and could print it out because it's nicer to work flat on a table with a paper. Maybe you're staring at this one on a screen, but everyone should have gotten the same one by email, so we all have the same numbers. And I also have a new version with just random numbers. So what we will do is one at a time, put the problems on the Jamboard. And on one side, we'll have like the official problems to work on together. And if people get stuck, I can give you hints by doing one with slightly different numbers. And let's make sure that everything is good and we're solid on everything before we go on to some of the more complicated things. Because in the future, once we start talking about the mad science topic, we've done fraction arithmetic, and really all we needed from shape-shifting was changing fractions to have desired denominators, factors, unreducing. But once we start getting to this other stuff, we're going to use a lot of our earlier material. So let's get it solid before we need it. I will pause the recording unless we're actually working together, or I'm doing an example on the board, so that this video isn't just a lot of waiting. So if you are watching this video after class, try the problems as we put them on the board, and then keep watching after. Pause it while you work on them, and then unpause it. Pause. So somebody suggested how to do this one. We'd write the two numbers side by side, line up all the place values nice. We start with the biggest place values. That's the same. The 8s are the same, but then we get a difference. So since the 4 is bigger than the 3, then that means that this one is bigger overall. The first time as we move from big place value to small place value, that something is bigger, then that one wins the contest. Because if you are wanting a lot of cake, the tenths of a cake matter more than the hundredths of a cake. And if you have more hundredths of a cake, then you don't really care about the other person's thousandths of a cake, and so on. So the bigger place values matter more. Problem 2, or rounding this weird decimal to the nearest tenth.
I believe you round the 7 to 8 because the 9 is higher than 5.
Yes, let me make it a little bigger so that we can see. So there's a 7. That's the 10th that we're being asked to round to. So we look at the thing that's next to it. And is that 5 or more? It is. Oops, or more. So that means we have to take the 7 and change it to something bigger. So we'll get 7987, and then that 7 turns into an 8. Okay, next one. For number 3, we have 248 divided by 47.1. Estimate that by rounding both numbers to the tens place. Okay, number 3, tell me what to do.
Okay, so you're going to round both numbers to the nearest tens place.
Okay, let me highlight that. There's a tens place. That's a ones. There's a tens place. Okay.
All right. The 8 is larger than 6. Therefore, the 248 becomes 250.
Okay. Well, the 8 is 5 or more. So yeah.
5 or more, sorry.
Okay.
And then the 7 is larger than 5 or more, so it becomes 50.
Okay. So we're roughly 250 divided by 50. So I have $2.50. How many 50 cents can I make out of that?
5.
Ta-da. Thank you. Okay, number 4, I'm not going to ask who wants to do it first. I'm going to do it first because it's always very confusing every year. So there's a famous TV show, Doctor Who. There's a famous scarf with all of these stripes of colors. There's an interesting story of why it was like that on the show. Anyway, ignoring the memes, then Susan has 5 partial skeins of yarn. They are all 1/3 of what a new skein of yarn would be. She wants to make a scarf using all of these different 5 colors. Each stripe requires 1/6 of a new skein. How many stripes can she make? So I'm going to do this first with pictures, if you like pictures, and then I will do it not with pictures if you're someone that doesn't like pictures. So let's draw what she has. So here is her 5. Everyone know what a skein of yarn is? It's kind of like a spool of thread, but the yarn version. Anyway, she has 5 of them, and they all have 1/3. And I've drawn them all in blue, but they're all different colors. She's going to make a very colorful scarf. Each stripe in the very colorful scarf needs 1/6. So I'm going to chop the circles more. If I chop each third in half, then we get 6. So how many 6 do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many stripes can she make? 10. Okay, here's the not picture way. She has 5 copies of 1/3. I'm going to take that 1/3 and I want to change it into 1/6. So how many 6 do I get for each third? I can change a third into 6 with a ×2. If I do it on the bottom, I have to do it on the top. So this becomes 5 copies of 2/6. And you can see that in the picture. Here's 2/6, 2/6, 5 times we have 2/6. Of, when we have a word problem with of, that turns into multiply. So it's 5 times 2/6. How do I multiply a whole number and a fraction? I take my whole number and make it a fraction over 1. Multiply across. 5 times 2 is 10. 1 times 6 is 6. So I have 10/6. And that 10 is our answer, because what we're wondering is how many 6 she has. Or not really me, Susan has. Before I ask who wants to do the official one from your version, any questions about what I just did on this side?
So when you're multiplying the 5 over 1, you don't have to get a same denominator to multiply?
Nope, for multiplying, we don't.
Okay.
For adding or subtracting fractions, you need common denominators. And if I look at our Jamboard from last time, maybe I can jog your memory. Syllabus, week 3, Jamboard. then so when I'm multiplying, I wanted 1/3 of 1/2. So I had a third, that was the dark yellow shading, the up and down third, and I wanted half of that. So I took half of the whole cake. I took the top and I said, there's the half I care about. So of that third, how much is mine if I get a half and maybe Joel gets the other half, right? Then the smiley face, my half of the third was the 1/6. So you can see the denominators multiply and turn into the 6 because I had thirds. The picture used to look like that, the thirds. But then when I took only half of, took only half of it, then that turned my thirds into 6. Multiplying across the top, 1 times 1 is 1. That's a little harder to see in the picture. I had 1 of the thirds and 1 of the halves. When we did it the next slide and had 2s and 3s, you could see the numerators multiplying also. So not my best explanation because I was trying to be a little quick, but did revisiting that from last class help, or do you want me to talk again more?
I think I'm good. Thank you.
Okay. So yeah, adding, yes, common denominators. Multiplying, no, because we're chopping cakes into smaller pieces. Okay, so Sequoia's answered some, Joel's answered one. Who else wants to do number 4, just like I did number 4, but with your numbers?
I'll do it. I don't know if it's
Okay.
right, but I'll try it.
Okay, are you going to want me to draw pictures or are you going to want me to just write numbers?
Numbers.
Numbers, okay, tell me what to write.
Okay, so 1/4,
Mm-hmm.
and then I just times the top and bottom by 6.
Okay. That is correct. Why did you do that, by the
Yay!
way?
To get 24. To
Okay.
get the 1/24.
Okay. So she has 3 of these things. Each of them is a quarter of what was new. She's used up most of them. Now these stripes are real thin and tiny. She only needs a 24th for each stripe. So how many 24ths were on each of these? That had a fourth. You did times 6 top and bottom. So each of the 3 has 6 24ths. Okay, keep going.
And then I did, let's see, 5. How did I get 5/1? That's not right.
You got the 5 by looking at this problem. This one, it's not a 5.
Oh, it's sorry. So I did it wrong. Okay, but it's 3. It would be 3/1.
Yes,
So my math is totally wrong, but I'll just redo it.
that's okay. We can do this. So 3 times 6.
Yeah, 18/24.
Yeah.
So it would be 18 is the number.
Yeah. She gets 18 stripes. Questions about number 4?
I'm good.
Okay, I'm going to pause the recording and put number 5 up on the board. Okay, number 5 is ready. If you are watching at home and wanting to try this yourself, hit pause. We'll be back. Number 5, how many factors does 104 have? This is different than the what's the prime factorization kind of question. Just in case you started with a factor tree, hit pause, try it the other way. You answered the other question. Okay, tell us what to do.
So I don't know if I'm right, but I got 8 factors.
Okay.
And what I did was I just seen how many times something can go into 104. So I got 1 and 104.
Mm-hmm.
2 and 52,
Mhm.
4 and 26,
Okay, let me say for just a moment, how did you know 3 doesn't work? You add up the digits, 1 plus 0 plus 4 is 5. Does 3 go into 5? No, so it doesn't go into this either. So 3 we skip. Yes, 4.
and
Okay,
26. And then I got 8 and 13.
okay. Yes, that is all of them.
That's what I got too.
So 8 factors. And to finish the skipped part, then does 5 work? No, it would end in 5 or 0. Does 6 work? Nope, 2 and 3 would both have to work. Does 7 work? There's no shortcut for 7, but you could either trust it doesn't work or try it on a calculator and see it doesn't work. 8 does work. Does 9 work? No, add up the digits. 1 plus 0 plus 4 is 5. Does 9 go into 5? No, so 9 doesn't go into this either. Does 10 work? No, because it would end in a 0. 11 doesn't have a shortcut, but at this point we're getting so close to the 13 that it would have to be 11 times 12, and we can know that 11 times 12 isn't the same as 104. At that point, we've sort of made a horseshoe. If there was anything bigger than 8 that worked, it would have to be on this side somewhere because it would need a small number to match up with. So there's not going to be any hidden factors. It's not like 18 might be a secret factor of this. There would have been something here for the 18 to match up with, and there wasn't. Here's number 6. If you're watching at home, pause it, try this, and then we'll talk about it. This one, the random number generator, was really mean. So as the instructor, I'm going to do the one on this side, and the class is going to do that one. So we have 2058, and to find the prime factorization, we use factor trees. So this is 2 times something. I can take out my calculator, that's allowed, and say 2058 divided by 2, and I get 1029. Now I have to figure out how this breaks up. So I go through my list. It's the same thinking we did on this problem before. So does 2 go into it? No, it's odd. How about 3? If I add them up, 9 times 2 times 0 times 1, I get 12. Does 3 go into that? Yes, 3 goes into 12, so 3 goes into this thing also. So what is that? 1029 divided by 3, and I get 343. Now I take this number and think about it the same as before. Does 2 go into it? No, it's not even, it's odd. Does 3 go into it? I will add up the digits. 3 plus 4 plus 3 is 10. Does 3 go into 10? No. Does 4 go into it? I look at the last 2 digits. 4 does not go into 43, so 4 doesn't go into this either. 5? No, 3 doesn't work. 6? Nope, because 2 and 3 didn't work. 7, I'm going to check on the calculator, and it does work.
49.
7 times 49. And then if we know our times tables, 49 is another 7 times 7. So overall, we got a 2 and a 3, and then 3 7s as our prime factorization. If you wanted to write it fancy with exponents, you could. 2 times 3 times 7 with 3 of those 7s. So put a cubed symbol up there, but writing it out the long way is fine. And some people like to circle the leaves of the tree where it stops, because that way you can double check that, yeah, I didn't forget any, because sometimes we're just careless writing it at the end. So that one was annoying. It had a lot of sevens. Sevens are not friendly. Should we try this side?
Yes.
Okay. So should I put someone on the spot that hasn't said anything yet, except for Tiffany, who's driving and we want her to drive safe?
Yeah.
Yeah, okay, I'll pause it so it's not too.
1 second. So do you start out with 2? Hold on, I don't have a.
I can be your calculator as well as your scribe. So 588 divided by 2 is 294.
Yeah, I don't have a calculator, so.
That's okay. The calculator is not the interesting part of these, so I'm happy to do that for you. Okay, now I need to break apart 294.
Do you do 4?
Do I do 4? I could try, but it's not going to work. If I do 294 divided by 4, I get something 0.5.
Do you divide by 3?
3 would work. I can tell that in advance because the trick for 3 is add up the digits. 2 plus 9 plus 4 is 15. Does 3 go into 15? Yes, so we'll go into this also. So 294 divided by 3, I'm getting 98 as the other number.
Does the 98 have to go on the left?
Doesn't matter. I'm
Thank you.
purposefully putting it on this side because if I stick it over here, I'm going to kind of run out of space on my paper. But it is a tree. You can flip it around how you want. Okay, how do I break up the 98 though?
I believe you can divide it by 7, right?
Yes. If you didn't see the 7, maybe you saw a 2 because it's an even number, but 7 will work also. And then when I plug it in, 98 divided by 7, I get 14.
7 and 2.
I'll write it the way you said, 7 and 2. Okay, so especially if you're like me and wrote it in such a way that your leaves are sort of all over the place, then I'm going to highlight the leaves so that I don't forget any. And then let's see what this is. There's a 2 and another 2 and a 3 and 2 sevens. If you liked it with the fancy exponent way, then you could write it as 2 squared times a 3 times 7 squared. But we don't have to show off with exponents. Thank you. Well done. Okay, number 7. What's the greatest common factor of 84 and 36? And for where we were about those divisibility rules, then you can go into the shape-shifting section and then divisibility and factors in the table of contents. And that's where all these rules are about how to know if it's divisible by 2 or 5 or 10 or 3 or 6 or 4 or 9. Okay, greatest common factor of 84 and 36. Number 7, what do I do?
I really have a hard time with these. Mm. Mm. I don't know. I'm sorry.
Remember when we said, show me all the factors of a number? We just sort of counted down on one side, listed the matching things until we got to the number that was the same size on both sides, more or less. So let's do that. Let's find all the factors. And we'll start with 84. So 1 times 84 works. What's next?
Mm. Mm.
We're checking 2. Is 2 going to work?
Mm. I think so.
Yep. You could try it on the calculator if you want to. You can see it's an even number. It ends in 4, so 2 will work. So we would wind up with 42. Is 3 going to work?
Mm. Mm. Yeah.
Yeah. I can hear you pushing calculator buttons. So 3 works. It's 28. The trick again for that was add up the digits. 8 plus 4 is 12. Does 3 go into that sum? Yes, 3 goes into 12. So 3 would go into this also. Does 4 work?
Mm. Mm. I think so.
When you do it on the calculator, do you have a calculator with you? It sounds like you do.
Yeah, I do.
So when you do 84 divided by 4, what do you get?
21.
21. Okay, is 5 going to work? Does it end in a 0 or 5? No, it's not a counting by 5 number. That doesn't work. 6 is going to work because 2 and 3 both worked. So do 84 divided by 6 and tell me what you get.
Um, mm, 14.
Okay. Does 7 work? That one you just have to try. There's no shortcut. And it does. 84 divided by 7 turns out to be 12. Is 8 going to work? No. 8 times 10 is 80. And I'm not adding another 8. If I'm counting by 8s, I know I will hit 80. So the next one is going to be 88. So that's not going to work. Does 9 work? The shortcut for that is you add up those digits. 8 plus 4 is 12. Does 9 go into 12? No. So 9 doesn't work for 84 either. Does 10 work? No, right? It would be 80 or 90. It doesn't end in 0. And is 84 11 times 11? No. And now we're back to where we started, right? The next number would be 12. So those are all the factors of 84. We could also say, what are all the factors of 36? This will go faster. We have 1 and 36. Does 2 work? Yes, it's even. 18. Does 3 work? Sure. 3 plus 6 is 9. 3 goes into that. Does 4 work? Yeah, it turns out to be 4 times 9. Does 5 work? No. Does 6 work? Yes, it's 6 times 6. And now we're back to as big as we had on the other side, so we can stop. So back to the original question, what's the greatest common factor? What's the biggest number on both lists?
Is it 6?
12.
12, I think. It's not 18 or 36. I think 12 is the biggest on both lists. Yay, thank you, Esmeralda, for helping.
Sorry.
So this is very slow and methodical. It's a little faster if you're good at those divisibility rules. But there's a quicker way to do this if you are making factor trees. Let's go over that with the other side. Now I'm looking for the greatest common factor of 40 and 64. So I will make my 2 factor trees. 40 is 4 times 10. Again, your trees might start different. Maybe you started with 2 times 20. That's okay. Factor trees are like that. So for 40, I got 3 2s and a 5. For 64, then maybe what, like 4 times 16, 2 times 2, 8 times 2, 2 times 4, 2 times 2. Now I'm looking for a factor in common, so I'm going to highlight all the leaves that appear on both trees. There's a 2, there's another 2, there's another 2, then these 2s don't count because there's not a matching one on the 40 tree. And this 5 doesn't count because there's not a matching one on the 64 tree. So I have 3 2s in common. So what's my answer then? 2 times 2 times 2 is 8. You could do the same thing with these numbers, the 84 and the 36, and you would get a 2, and a 3 to make 12. Another one by request, 150 and 210. Should I do it the list all the factors way, or should I do it the common leaves of trees way?
Factor way.
The first way, all the factors. Okay. So 150 and 10. So for 1 times 150, that works. Does 2 work? Sure, it's even. What's half of $1.50? Yep, 75 cents. Okay. $1.50 would be 6 quarters. Half of them is 3 quarters. Okay, 3, does 3 work? If I add them all up, 1 plus 5 plus 0, I get 6. Does 3 go into 6? Yes, so 3 will go into this also. It's 3 50s, right? 50, 100, 150, counting with quarters again. Does 4 work? For 4, the trick is to look at just the last 2 digits, 5, 0. Does 4 go into 50? No, as I count by 4s, I would go 40, 44, 48, 52. I would skip over it. So 4 doesn't work. Does 5 work? Sure, 50 is 5 times 10. Does 6 work? It will, because 2 and 3 both work. If I don't want to do 150 divided by 6, I could say, well, for 3 it was 50. So for 6, it's going to be half of that. I'm going to take a 2 and move it here to make 6. So what's 50 divided by 2? Half of 50 cents. 25, I see. Does 7 work? No, it's not going to work. Does 8 work? Well, 4 didn't. So we're done with 2, 4, 8, like that pattern. Does 9 work? If I add up the digits, 1 plus 5 plus 0, I get 6. Does 9 go into 6? No. And whoops, I did the wrong thing. I'm thinking 5 times 10, and it's wrong. It's 5 times 15. Yell at me when I make a mistake. Okay. No, it's 5 times 30. Okay, there we go. So 9 doesn't work. Does 10 work? Yep, it's 10 times 15. Does 11 work? No. 12? No. 13? No. 14? No. So then we're up to 15. We're done with that one. Sorry, I made a mistake. I was too eager with times 10s. Okay, on the other side, 1 and 2, 10. Does 2 work? Sure, half of 210 is 105. Does 3 work? I add these up. 2 and 1 and 0 makes 3. 3 goes into 3, so 3 is going to work. Use your calculator if you're not sure what it is. Does 4 work? I look at just the last 2 digits. Does 4 go into 10? No, 4, 8, 12. We skip over 10, so 4 doesn't work. Does 5 work? Yes. Does 6 works? It's got to, because 2 and 3 both worked. So half of 70 is going to be 35. 7 does work. There was a clue about that earlier when we had a 70 here. So 7 is going to work. 8, nope, 4 disqualified us from 8. Does 9? 2 plus 1 plus 0 is 3. Does 9 go into 3? Nope, so 9 is not going to go into this. Does 10 work? Yes. $11, no. 12, no. 13, no. 14 is actually going to work. You'd have to just try it. And now we're up to 15, which is a number on the other side, so we stop. Okay, what's the biggest number on both lists?
$15.
15. No, there's one bigger. 30, I see in chat. 30 is on both lists.
So why wouldn't it be 15?
Because it's asking what's the greatest common factor. 15 is certainly a common factor, but it's not the greatest one.
Oh, okay. That makes sense.
There are lots of math classes that spend a lot of time writing initials on the board, and they will say GCF or something like that, or GCD for greatest common divisor. But when you look at the initials, you forget that it's just saying what it's saying. It's saying, look at all the factors. Let's take all of the common ones. 15 is a common one. 6 is a common one. 5, 3, 2, 1, right? There's lots of common factors. But of these, which is the greatest common factor? The 30. The 10. Ready to move on?
Yes.
Yeah.
Okay. Reduce the fraction 12/42. So paste it there. Tell me what to do for 12/42. I'm not going to pause because I think you can do this one pretty quick. Pause if you're at home and working on this and don't have it right away.
You divide by the greatest common factor.
I could to do it all in one step. Yes. If I don't, I'll just reduce it more than one step, and there's no problem with that. So what should I divide by this time?
I got 6.
6.
6. 12 divided by 6 is 2. 42 divided by 6 is 7. And I have 2 7ths. Yay. Just to put it on the board, if you didn't divide by 6, maybe you are being slow and careful. You could say, well, they're both even. I'll divide by 2. And they're both multiples of 3. And I get the same answer. I've just broken apart my 6 into a 2 and a 3. So it works. Okay, tricky time. That one didn't load up the right way. Now we have a fraction that has a decimal in it. I'm going to write it better because it's always nicer to put fractions of one number right on top of the other instead of slanted. So 3.6 over 38. What an ugly thing. So pause it at home. I'll pause it. Okay, how do we deal with this icky thing?
So I believe you would times by 10 to the top and bottom to get the decimal to not be a decimal anymore.
Right, let's get rid of that decimal. No one wants it there. So times 10 causes a decimal point scoot. And now we have 36 over 380. Whoops, I wrote a mistake. Where did I write a mistake before I fix it?
I'm not sure.
I'll give you a hint. One of my arrows is bad.
On the 38?
Yeah, I need to start where the decimal actually is. I was making things match too much. So that's a 38.0. So that's where we get the 0 from for 380. Okay, now we're in familiar territory. This is just like the one we did before. We have one number on top of the other. The decimal is gone. We can handle this. What next?
Divide by 4 to the top and bottom.
Okay,
9 over 95.
okay.
And I believe that's it, but I'm not sure.
Yep. Anyone want me to do the other test version of it?
Sure.
Sure. Okay. So reduce 10.8 over 66. So as before, I want to do 1 decimal point scoot to get rid of the decimal in the number that has 1. That's just a times 10 top and bottom. Second way to write the same thing. And then I get 108 and 660. Those look like big things. What can I divide by? I'll try 4. The hint for 4 was to look at the last 2 digits. Does 4 go into 8? Yes. Does 4 go into 60? Sure. So I'll try 4. So I'll get out my calculator, do those things. 108 divided by 4 is 27. 660 divided by 4 is 165. Then 27, that's going to be 9 times 3. Does 165 have 3 as a factor? I'll add them all up. 6 and 1 and 5 makes 12. Yes, 3 goes into 12. So 3 is going to be part of both of these. 27 divided by 3 is 9. 165 divided by 3 is 55. And that's as far as that one reduces. The random numbers were kind to us for 10. Write 2/10 as a decimal. So do that, pause it, and then see what we're doing. I put one from the other version of the test also, 2/20 as a decimal, slightly more challenging. I would work on that one too before you unpause. Okay, who wants to tell me 2/10? Don't think too hard about it.
I'll do it.
Okay,
So you divide 2 divided by 10
you do.
and you get 0.2.
You didn't even have to divide because this you can just say it's 2/10, right? That's just how you say that decimal.
Yeah.
But for the other one, for 2 divided by 20, then yes, dividing is the right thing to do. There's other ways to do this problem. None of them are faster, so I don't recommend them. Taking the fraction and saying top divided by bottom on your calculator is a great way to do this. You don't have to think about, is there some clever trick that I'm missing? It works, it's fast, great. But just to be complete, so no one fusses at me, because who knows what people do once I put this on the internet, then I could do this 2 other ways. I could look at my 2/20 and say, hey, I can reduce that. And that gives me 1/10. And I will just say that 1/10 and know that that's 0.1 because that's 1/10. Just like I could look at this one and say that's 2/10. So yeah, maybe that makes you feel smart. It's clever, but it's not any faster. Or I could be very clever and say, I'm going to take 2/20 and going to multiply top and bottom by 5. And then I will get 10 hundredths, which is another way to make the denominator one of the one of the decimal place value names, like tenths or hundredths. Then I could write that as 10 hundredths. And that's also an okay thing to do. And you don't need to put the 0, but it's not wrong. But that's even more convoluted and slow. So yeah, this is good. This is fast. This always works. You don't have to be clever and notice how to make the denominator a tenth or a hundredth or something like that, even if you can. Just do top divided by bottom. Fast, easy, good. For number 11, I'm not going to use our right and left side of the screen for two different versions because it just won't be legible if I shrink this that much. So brand A costs $26.28 for 13 ounces. Brand B costs $20.75 for 11 ounces. What's the price per ounce for each, and what's the better buy? And I'll just want to say that price per ounce what arithmetic thing do we have the word per become?
Would it be division?
Division. So this is going to be a division problem. The price divided by the ounce. So pause if you're working at home. Does anyone just want to do this one for us? I think we should pause first in class 2 and give everyone a chance to see if they know how. And someone put in chat that what I wrote didn't work. There we go, all fixed.
I just didn't want it to confuse whoever was going to be looking at it.
Yes. Well, as you can tell, I think about what I'm going to say too much and not what I'm writing at the moment enough. So I make lots of typos, but that's okay. Okay. So price per ounce, we have brand A and the brand B. Tell me what to write for brand A.
Would it be 26.28 over 13?
Yeah, I'm not going to write over. I'm just going to write divided by because that fits on my screen better. But if you like to write it as a fraction over, then you can do a fraction bar instead of a division symbol. So I do that and I get roughly $2.02. And that's my price per ounce. Okay, for B, same thing. I just take the numbers and plug them in. So 20.75 per, that's the price. Right? The per is division. The ounces are 11. And whatever my calculator says that is, about 189. So if I buy just 1 ounce of stuff, which brand is the better deal?
Brand B.
B. Okay, number 12. This one again, unless you really want me to, I'm not going to do an extra version of it just because of, unfortunately, once I've made something a PDF, I can't resize it. With this one, if I want to rearrange it, I can go wee like that. But to make it fit on the board, I sort of have to have it go all the way across. Okay, Stalwart the Wonder Snail crawls 34 yards in 11 minutes. And the hint is to try and start with finding yards per minute. Then, how many yards would it crawl in 71 minutes? This one, I'm guessing, has a few people stumped, and maybe we should just see who wants to do it, or do you want some time to struggle with it if you're stumped?
I can do it.
Okay, tell me what to do, Sequoia.
So I did 34 divided by 11.1.
Okay, so first I just plug things in that spot. The yards, per becomes division, 11.1.
And I got about 3 yards per minute.
Oh, okay. I'm gonna keep a few more decimal points just because I know if I round in the middle, I will change things. It won't matter too much. Okay, so every minute it goes that many yards. Then what?
Would you multiply that by 71?
Exactly. Now, if I could somehow hold up my calculator in a way that made it legible, I would do that, because I don't have to actually worry in real life about how much rounding I did here. That's just because I have a whiteboard. I have a number sitting on my calculator screen that's not rounded. It just goes on and on off the edge of the screen, right? So when I hit times 71, it's going to use the real number. And so I get this nice answer of 217.4. So maybe about 217 yards. And I'm not worried about loss of accuracy from me rounding on the board, because on the calculator, I just took that long number that went on and did times 71 equals. Did anyone do something with a proportion and cross multiplying to solve this one? No answers. Okay, we haven't talked about that yet in class. So if you knew that from another math class, yes, you can do cross multiplying to solve this, but that's getting ahead of where we are. I'm not going to do that today. Okay, 13. I'm finding a population density, a unit rate. I have to know which order to do these things. Do I use this number first or that number first? Pause it if you're working at home and think about it. And someone can just tell me, how do I know which number comes first when I put things in the calculator?
Would you do the people first?
Yeah. As I read it, it's people per square mile. So just as with the previous slides, I write that out. People per square mile. And that tells me the order to do things. The people is the 798, 700. Per means division. And 5.2 is the square miles. So I'm getting about 153,596 people per square mile. There's nothing about the numbers themselves that make an order happen. It's just what the question asked me. The question could have said, as a different question, what's the square miles per person? In other words, how much land would each person get? We could divide in the other order. It would make sense as a thing. It's just not the thing for this question. Okay, these, we could fit one on the left and one on the right from two different versions, but I think these are easy ones that you don't want two versions of anyway, but I'll make more if we need them. Pause if you're at home. Otherwise, just tell me, because you're here, what were the shortcuts for dividing by 10 and dividing by 1/10, 100th, 1,000th, 1,000th?
Would you scoot the amount of zeros?
I scoot where the decimal is. Was a division by 10 left or right?
Left?
Left. And how many scoots left?
1.
One. Ta-da. If you ever forget the rules, then go back to watch that class video and try them on the calculator to double check that they really work. And you don't just have to believe me. Okay, how about division by 1,000th?
Three scoots left.
It is 3 scoots, but it is no longer left.
Right.
Right. Yeah.
So if there's a decimal, you do it to the opposite way.
I do. This number is a little awkward. So let's just think about a simple one. What if we had 5 divided by 0.1? Have friendlier numbers for our thought experiment. So this is saying I'm taking 5, whatever, cakes, and I'm chopping them up into tenths. How many pieces do I get? So the rule we just said is that I'm going to go 1 scoot, but if a divide by 10 was left, divide by 10th is going to be right. So I'm going to get 50. Does it make sense that if I have 5 cakes and chop them up into tenths, I have 50 pieces?
Kind of.
Kind of. Can you picture one cake having 10 slices and another cake having 10 slices and so on? So there's 50 slices.
Okay, yeah, that makes more sense.
Right? This is like some, I don't know, a big wedding where you have 5 sheet cakes because there's so many guests and everyone gets a tenth of a cake. So there's 50 slices to pass it. That's a big slice of cake. But anyway, you know what I'm trying to say. So think of dividing by decimals as chopping things up into bitsy pieces. So here we had a lot of some things, whatever that was. Hopefully not wedding cakes. And we're dividing them up into tenths, hundredths, thousandths. So each one becomes 1,000 little fragments. We get a lot of things. Okay, 16 I'm going to skip over. 17. And 18. So we had 599.471, and it was a percent, and I wanted to replace that percent with something else. What was the easy thing to replace it by? Think about that at home. Then the 18 was I had 250.47, and I wanted to add a percent symbol on, but I can't just do that. That would change the number. That means out of 100, not wholes. So I had to do something else to be fair and compensate. So pause if you're at home, and otherwise tell me what to do because you're here. Everyone remember the acronym RIPLOP?
Right into percent, left out of percent.
Yeah. If you didn't remember that, then it's in the percents, decimals, and fractions thing. There's a there, yeah, RIPLOP right there. I can even grab it for this thing. So for number 17, we're going out of percent. We want to get rid of that percent symbol. So we are going left out of percent. For number 18,
Why would you only scoot 2?
why would I? Because percent always means out of 100.
Oh, okay.
So I'm always replacing this with a times 100 or a divided by 100.
Okay.
Good question. Now I'm going into percent. I don't have a percent. I want to put one there. So I go right. And that makes it bigger by a times 100. So then I'm allowed to put my percent symbol on, which is the same thing as make it smaller by 100. They cancel out. So if you need more practice with those, then again, that's the percents, decimals, and fractions in the shape shifting. I didn't really wait for people to try them off on your own in class here because this is supposed to be something you just do real quick. Left twice, done. Right twice, done. And if you don't know the trick fast, then you're doing it too hard. You're making a mountain out of a molehill. Should we do more of these?
Yes, please.
Okay. We do this all the time. Your calculator might have a percent button. However, it's terrible. It doesn't do what you want. It doesn't do the same thing in every situation. So whenever we use percents, we use RIPLOP. If we're given a percent, we scoot to get rid of the percent as we plug it in the calculator. If the answer wants a percent, we'll use RIPLOP at the end to turn our calculator answer into the percent that we're asked to do. Okay. So for the top one, into percent or out of percent?
Out of percent.
Out of percent.
A percent.
So left out of percent. For the bottom one, into percent or out of percent?
into percent.
into percent. So to the right. Ta-da, quick and easy.
I have a question, but it's not about this. Are you wanting us to skip over 16 too, or do you want us to do that on our own?
16 I am skipping just because of what is happening. I'm happy to talk about it. It just doesn't work very well in this type of class. So in shapeshifting, when we looked at the 4 replacements for percent, everyone remember this thing here? If
Yeah.
not, then go into the syllabus and percent decimal fraction switching week 2 Tuesday, do that thing. So if you were there in class, if you watched the video, then it kind of makes sense to you that there's these 4 different ways to switch out of percent. And in some situations, this one's easier. In other situations, that one's easier. You have that background context. So in number 16, then the problem is saying, here's one of those contexts. I have a fraction with a percent sign after it. Which of those 4 ways do I do? And sometimes it's obvious. Should I do decimal point scoots? No, there's no decimal points to scoot. That's not going to work. Let me reload. 45%. Should I do decimal point scoots here? Yeah, that one is the right one to do for just a whole number with a percent after it. If I wanted to make this into a fraction, should I write it as 67 over 100? Sure, that's the good one for making a fraction. But if I wanted that as a decimal, would I use times 1 over 100? No, that's the wrong one of these 4 options if I'm wanting to quickly get a decimal. Does that make sense?
Yeah, thank you.
So it's asking, if you saw that lecture, did you understand how there are these 4 things, and picking the right one makes your life easy. So that all of these rules like riplop actually make sense. You're not just memorizing something without knowing why it works. But if you haven't seen that lecture, then you have no idea what 16 is talking about. Is it most efficient? Efficient of what? What are the options? It doesn't explain that there's these 4 things and you're picking which one it happens to randomly give you and see, is this the right one for that or not? So it's something that you should be able to do. It's something the answer key tries to explain, but maybe not. Maybe it just says yes or no. If it's no, it tells you which one is better. But it's just a little awkward to talk about without going back and redoing this whole lecture, which I don't want to do right now. So that's why I skipped it.
Okay, thank you.
Okay. Where were we? 18. Now we're doing fraction to percent. So I have 5/25. I want to make that fraction into a percent. It would be nice if I could use riplop. Riplop was fast and easy. So how do I get there?
Can you divide 5 into 25 and get a decimal and then make that a percent?
Exactly. So I take 5 divided by 25. I get 0.2. Then I say I'm going right into percent. And that's 20%. Okay, pardon me for being annoying, but just like before, some people are clever and like to do clevery things because it makes them feel smart. So if you did this a different way, you could have said, I'm taking the 5/25ths. I notice that this particular fraction, I can make a 100 on the bottom. And that gives me 20/100ths. And 20 out of 100 is the same as 20%. But that isn't any faster. And it requires you to stop and notice that this happens to be a denominator that I can make into 100, because only over 100 can I replace with a percent sign. Most denominators I can't make into 100, of course. So this is the nice one. This always works. It is always fast. This one, if you notice that 25 can become 100, you can be clever, good for you. But if you're doing group work with someone, probably don't distract them with that. But I recognize you, you're okay. Okay, let's do one more just because I'm not going to do it the silly clever way. 3/48 as a percent format. So don't think about it, just start right away. What do I write first?
3 divided by 48.
You divide it by 48. Yep, that's the right way to start. It is fast, it is easy. And I get 0.0625. And then I say I have a decimal. I am going right into percent. And I get 6.25%. Quick, done. Happy problem, easy points on a test. Ta-da. Okay, now this one was very different. What is 6 2/5% as a fraction? I'm guessing I will actually want the left and right hand side of this. Oh, come on, where's my left and right hand side? Okay, pause if you're at home. Try this one. This is one that often I need to give a hint on first before someone does it on the left. So I'm happy to do that. So we take the 6 2/5%, and we're first changing the 6 2/5. 6 times 5 is 30, plus 2 is 32 over 5. But don't put a box around this. It asks you to write it in fraction format, but we're not done. And why aren't we done?
Because you still have the
I
percentage.
still have a percent. It hasn't gone anywhere yet. Okay, and now that I'm remembering.
32 over 500.
This is times 1 over 100. I'm actually going to do a little bit of canceling, as we've done canceling now. So half of 32 is 16. Half of 100 is 50. And then we get 16 over 250.
Do you have to simplify that? Oh, okay, you don't have to.
I don't have to. Oh, wait, no, I do, because it's still even on both sides. I am sorry. I am again thinking too much of what I am going to do and not what I just did. So that's 16 over 250. I could cancel more, but I'll just start reducing. No, that's only divisible by 2.
8/125.
8/120. Thank you, Randy. I'm not remembering my own rules because I'm rushing. Could 250 be divisible by 4? No, because the last 2 digits, that's not a multiple of 4. Counting by 4s, I would go 40, 44, 48, 52, and skip right over that. Should we do this side also for anybody?
Sure.
Okay, so 8 3/5 is a percent. 8 3/5, 8 times 5 is 40, plus 3 is 43. That many fifths still is a percent. Replace the percent with times 1/100. This is going back to, again, which of these things works best in which circumstance. And 43, that's not going to have any canceling or reducing. So I'm happy and done. Okay, we're to the last topic. We're doing measurement things. It's also after 7:50. If anyone needs to like stretch your legs, take a quick break, you can. I think I'm just going to plow through this. It doesn't really make sense to stop. Is there someone that wants to be sure I do a certain homework problem before I'm done so that as I approach 8:20, I don't just keep going through this and skip your homework request? So how many milliliters are in 99.471 cubic centimeters? Who remembers the trick for this one?
Do you move the decimal?
For metric to metric stuff, I normally do decimal scoots, but that's not this problem.
Is it the KHDUDCM?
Same thing. That's would be normally what I do for metric to metric, right? SI to SI, but that's not this problem. That's one coming up. This is going back to the history lesson. We have milliliters and we have cubic centimeters. Oops, and that shouldn't say cubic centimeters. That should say cubic centimeters. There's a typo in the test. Okay, I fixed the typo for the future. So the answer to this one was 2 names for the same thing. Both of them are, I have a little cube. It's 1 centimeter on each side. Whether I call it a milliliter or I call it a cubic centimeter, it's the same thing. So the answer is that. It's not changed. What you wanted to do was $25. This is the one where we're saying 7987 meters is how many millimeters. So as you mentioned earlier, we make our letters K, H, D, U, D, C, M, and then we look at where we start and end up. So someone take over from here.
Would you start at the U
We start at the U because that's just plain meters.
and then go to M?
And we go to M, which is the millimeters. So from here to here, 1, 2, 3 to the right. So we take that and go 1, 2, 3 to the right, which is going to put 3 zeros after it. And we're done. Should we do another one like 25?
Yes.
Yeah, okay. Let's round it so it's not. There we go. That's different. So now we're asking 5875 meters is how many kilometers? So K, H, D, U, D, C, M. King Henry does usually drink chocolate milk. Killer hobos dance under dazzling crystal mobiles, whatever you want to remember that. If you have a good one, let me know. I'll put it on the webpage. But for this, where are we starting? Where are we ending?
Unit
Unit, the plain meters.
and ending at the K.
Yes. And ending at kilo. So from here to here, 1, 2, 3 to the left. So 1, 2, 3 to the left. And we're done.
Thank you.
You're welcome. Okay, we did skip over a few. Let's do 22. I'm going to leave it small because it's annoyingly hard to read anyway. So we're wondering 570 meters is how many feet when we know that 1 meter is about 3.281 feet. So if you went into shapeshifting and we talked about one-step conversions, then there were these rules about, do you multiply or do you divide? We're going to do one or the other, but it's nice to have the rules to know which to do. What is it in this case? Are we multiplying or dividing the 570?
Do you
Right.
divide?
Right. So the rules said So a meter is multiple feet. Feet are smaller, lots of them fit in a meter, just like inches are smaller, lots of them fit in a foot. So when we're going from the multiple measurement to the smaller one, then we multiply. So this one would actually be a multiply. And whatever that is. If you wanted to round it to 1870, that's great. It's not quite clear on these how precise the initial measurements are. .24 is very similar. Oops. So 121 kilometers is how many miles? And what I know, as they tell me, is that 1 meter equals 1 point. Whoops, that says meter. That should be a mile. I really need to find that and fix it. How could that not have been discovered in a past term? Okay. Okay, I'll have to fix the code after class. So anyway, 1.61 kilometers is a mile, and 121 kilometers is how many miles? So is the mile a bunch of kilometers or the kilometers a bunch of miles?
Kilometers, a bunch of miles.
No, other way, the miles has more than one of these. So we're going from the smaller thing this time, the one that fits into the bigger one. So that's smaller thing means divide. So if you are like most people and hate these, you never can be sure if you multiply or divided the right way. As soon as things get a little awkward with measurement units that aren't nice and familiar, like inches and feet, it just stops being intuitive. Don't worry, we are about to get to a better way to do things with proportions and cross multiplying. But for now, this is the way we know. But if this is like the worst part of your practice test, is these measurement conversions that are not enjoying the shortcut, then that's okay. There will be a better way to do these. Kilometers to meters is just like the other ones that are metric to metric and have scoops. Centigrams to kilograms. Again, we're going from centa all the way to kilo. Same kind of thing. Square roots. This was just a calculator problem. No one is asking you to know a way to do this with long division or something. This is like a freebie point on the test just to make sure you're ready for your next math class. Can you plug in square root of 10,201 equals and get the answer on your calculator? So I went over that briefly because we're out of slides. We're at 20 over 20 and time is pretty much almost up. Do you want me to do the last bit of these in detail? Do you want me to do a little bit of what we're doing next class, just so you see it twice and it sticks in your brain better? Do you want to leave 9 minutes early because you're tired? What should we do?
9 minutes early because I have stuff I need to do.
Okay. I will stop the recording. If
And
anyone wants to stick around